In this problem, two positive ions, each carrying a charge Q, are separated by distance d. If F is the force of repulsion between the ions, the number of electrons missing from each ion will be. So here, each ion, so many electrons when come out, then the ion becomes a positive. So some missing electrons, lack of electrons, a positive. So how many electrons are missing, we don't know. So let missing electrons is equal to some n. So charge on electron is equal to E. Therefore, each ion charge is equal to plus Ne. So this we take both are same charge, so this is the charge they are having. So let us take, this is the charge Q. So let us come back to the problem. Two ions are there. This ion charge is equal to Ne plus Q, right? This charge also plus Q, that is also Ne. The distance between them is d. So let us calculate the force. Force formula K Q1 Q2 by R square. Here R is given as d square. K is 1 by 4 pi epsilon naught. Q1 Q2 both are same, Ne into Ne. So n square E square by d square. This is the F. So let us write once again the equation. F is equal to what we got, 1 by 4 pi epsilon naught n square E square by d square. This is the force. What value we need? N square value. So I will write this F into 4 pi epsilon naught d square is equal to n square E square. So n value we need. That implies n square is equal to F 4 pi epsilon naught d square by E square. So finally our n value, n is equal to under root F 4 pi epsilon naught d square by E square. So this is our answer. Let us check which option is correct here. So 4 pi epsilon naught F d square by E square. So fourth option is the correct option. Like that we can simply do the problem. This is given in, it is a previous NEET problem. In this problem, n fundamental charges, each of charge Q, are to be distributed as 2 point charges separated by a fixed distance. The ratio of maximum to minimum force between them is. So here important point is n is even and greater than 2. So let us solve it. How many fundamental charges are there? N. Each fundamental charge having charge Q. Therefore, net charge is equal to number of charges into charge. So this is the net charge. This charge is divided into two charges, 2 point charges, right? If this charge is made as 2 point charges, then Q1 charge is equal to some n into Q. N is a natural number, right? And Q2 is equal to, see, n already came out. So remaining charges are n minus n into Q. So this n is not greater than capital N and this n is a natural number. So two charges. Now what given in the problem? One charge is there. That Q1 charge is equal to NQ and another charge. Both are similar charges. So we can take it as plus Q1. So Q2 is equal to plus n minus n into Q. These two are fixed at some distance r. So naturally we used to take the distance between the charges are r, otherwise given. The last problem, the distance between the charges is given as capital small d. So small d we have taken. So generally we used to take r symbol. So symbols are not important, their meaning is important. Okay, let us calculate the force. Therefore, force, Coulombian force, what it is? 1 by, if not K, Q1, Q2 by R square. This is the formula. That is equal to K, small k, right? Q1 is NQ, Q2 is N minus N into Q by R square. So K, Q square by R square, remaining is N into N minus N. So this is the equation we got for the force. So when do this force will be maximum? When do this force will be minimum? Maximum force to minimum force ratio we've been asked to calculate. That's why, yes, maximum force. When do the force will be maximum? If the magnitudes of both charges are equal, then the force will be maximum. So that means what? Q1 must be equal to Q2. Then the force between the charges will be maximum. What is Q1? NQ. What is Q2? N minus N into Q. Right? So now this Q will go. So what we got? N is equal to N minus N. This minus N comes this side. 2N is equal to N. So small n is equal to N by 2. So if and only if N is equal to N by 2, the force between the two charges, the Coulombian force, whether it may be a attractive force or repulsive force, that will be a maximum in a magnitude. So let us write, therefore F maximum is equal to, so for F maximum N is equal to N by 2. So K Q square by R square. In the place of N, I will write N by 2. N in small n place, I will write N by 2. In small n place also I have written N by 2. Then F max is equal to K Q square by R square into, this is N by 2, N minus N by 2 is also N by 2. So N square by 2 into 2, 4. This is maximum, right? So when do this become, what is the condition for minimum force? Minimum force. So when this product is minimum, then it will be very less, NQ and N minus N. So both must be less. The product must be less, then only The minimum force will be the, see, Q1, Q2 must be minimum. And what we know, n is greater than 2 and it is a even number. And even number. So n must not be is equal to or greater than n. See, so greater than capital N not possible. So minimum value less than 2 is n must be equal to 1. So if n is equal to 1, what happens? F minimum, I write F minimum. Now n is equal to 1 is our condition. KQ square by R square. In the place of n, I will write n. In the place of small n, I will write n. So I got F minimum is equal to KQ square by R square into n minus 1. This is equation 3. Don't forget, okay? So minimum means the product value must be minimum. So here small n, capital N both are there. Capital N is a even number greater than 2. So our number, whatever the small n we have taken, that must be less than 2. Less than 2 means 2. Less than 2 is 1. That's why n value is equal to 1. So if we take n value is equal to 1, we'll get a minimum value of force. So what we've been asked? So we've been asked to calculate F maximum. Therefore, F maximum by F minimum is equal to F maximum value KQ square by R square into N square by 4 into. So this formula we have to write in a reciprocal way because by came na. So R square by KQ square into n minus 1. So what are the things cancel each other? Here KQ square, R square cancels. So we left with the n square by 4 into n minus 1. So our answer is n square by 4 into n minus 1. That is the, so let us write this one. Therefore F max by F minimum is equal to n square by 4 into n minus 1. This is not always correct. For this given condition, what is the condition? N fundamental charges are there, that n is even and greater than 2. Then we have divided into two separate charges. The total charge available is nq. So in that we have to separate two charges. So we have separated as nq and n minus nq. So that is small n should be less than 2. That is possible. The one number is 1. That's why we have taken 1 for the minimum condition. So let us see which option is correct. So n square by 4 into n minus 1. So here it may be a typing mistake. So second option is the correct option. This problem, 2 point charges Q1 and Q2 are placed in vacuum at distance R0 and the electric force between them is F0. Now the space between them is filled with a dielectric medium of constant K. It was observed that if the charges are placed now at distance R, the force between them remains the same. Then so the relation between small r and R0, small r0, we have to establish. So what given? Q1, Q2 charges are in vacuum. Then F0. So F0 formula is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. Equation 1. So this is R0 they are telling, right, when it is in vacuum. So in vacuum. In medium, so in medium, force formula is 1 by K into 1 by 4 pi epsilon naught Q1 Q2 by R square. This is in dielectric medium. So what they have given, both forces are equal. So Fm is equal to F naught. Then Fm formula 1 by K 1 by 4 pi epsilon naught Q1 Q2 by R square is equal to 1 by 4 pi epsilon naught Q1 Q2 by R naught square. This is since equation 1 and 2. So what are the common things? Cancel 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, Q1 Q2, Q1 Q2 cancel. So we left with 1 by K R square is equal to 1 by R naught square. So from this K R square is equal to R naught square. That implies R is equal to R naught by root K. So this is our answer. So let us see which one is the correct answer, which option. So option 3 is the correct answer. In this problem, 2-point charges A and B having charges plus Q and minus Q respectively are placed at certain distance apart and force acting between them is F. If 25% charge of A is transferred to B, then force between the charges become. So let us take charge A and charge B. So these two charges are at a distance R. Here this charge is plus Q and this is minus Q. So force acting between them is equal to K Q square by R square minus. This is the force. Now what happened? This is charge A, this is charge B. The distance not changed, it is same only. Now 25% of this charge is given to this one. So here only 75% will be there. So 3/4 of the charge will be remaining here. Here 1/4 of the charge is given to this one. So here how much charge will be there? 3Q minus Q. 4Q minus Q is plus Q is 3Q minus 3Q by 4. These are the charges. So Q1 3 by 4Q and minus 3Q by 4. Now force is, so F dash new force is equal to K. This is 3 by 4Q into minus 3Q by 4 by R square. So let us simplify this one. F dash is equal to K, 3 3s are 9, Q square by 4 4s are 16, R square minus. This is 2. So we will compare equation 1 and 2. From equation 1 and 2, see minus kq square by r square we will take as f. Minus kq by r square is f. So f dash is equal to 9 by 16 f. So this is our answer. Let us see which option is the correct one. So this question is given in NEET 2019. So answer is 9 by 16 f. So second option is the correct option. In this problem, two identical charges conducting spheres A and B have their centers separated by certain distance. Charges on each sphere is Q and the force of repulsion between them is F. So force of repulsion, that's why both charges are similar charges. A third identical uncharged conducting sphere is brought in contact with sphere A first and then with sphere B and finally removed from both. New force of repulsion between the sphere A and B. Radii of A and B are negligible compared to the distance of separation, so that the calculating force between them, they can be considered as point charges. So we have to consider these spheres as a point charges. So new force of repulsion between the spheres A and B is best given as. So new force of repulsion we have to calculate. Okay. Let us take two charges. This is A, this is B. A is having plus Q, B also having charge plus Q. The distance between these two is R. So the force is given as K Q square by R square, or Q1 Q2. Both are same, so kq square by r square. This is equation 1. Now what happened? This is charge A, this is sphere B. The distance between these spheres same, but what happened? A new sphere. This sphere C is not having any charge. But here it is having plus Q charge. This is also having plus Q charge. Now if these two are touched each other due to conduction, what happens due to conduction? The charges will flow from A to C till the charge on both of them, the potential on both of them becomes the same. So average charge will come and sit on both of them. So this A also having Q by 2 charge. This C previously no charge. Now it got Q by 2 charge. Right. Now after that, this C and B are made into contact. So what happens? Charge will flow from this B to C till the charges on both of them becomes equal. So here what happens? This Q will not be there here. How much will be there here? Plus Q by 2 is equal to how much? 2Q, 3Q by 2 by 2 average. So 3Q by 4. So here this charge will not be there, plus on it 3Q by 4 charge will be there, right? These two are came into contact, so average force charge will be on both of them. These are two are made into contact, average charge will be there. So finally what happened because of this? This sphere A, this sphere B, the distance between them is R, but here charge is Q by 2, here charge is 3Q by 4. Now new force let us calculate. F dash is equal to K, Q1 is Q2 by 2, Q by 2, this is 3Q by 4 by R square. So So that is equal to 3, 4 2s are 8. So K, before that I will write 3 Q square 8 R square. Right? So KQ by R square is equal to 1. This is equation 2 from equation 1 and 2. What happened? F dash is equal to 3 by 8 will be there only, but in the place of KQ square by R square we write it is F. So this is our answer. So let us see which option is correct. Right. For this problem 3F by 8, option 4 is the correct option. In this problem, two identical charged spheres suspended from a common point by massless strings of lengths L are initially at distance D. D is very much less than L apart because of their mutual repulsion. The charges begin to leak from both the spheres at a constant rate. As a result, the spheres approach each other with velocity v. Then v varies as a function of distance x between the spheres as. So here previously the distance between them is d, but now what happened? What is the initial displacement between them? We don't know. But when we observed, they are at some distance x. So both are having same charge. This is plus q, this is also plus q. This normal will bisect. That's why this distance is x by 2. Length of this thread is string is L. Right. See what are the forces acting here. This q will repel this q in this direction, and this one is having some mass. So like this, its weight is acting. So these are the forces acting on this. And now here in this right angle triangle, this is hypotenuse, this is one side. So the other side we can write as L square minus x square by 4. O I will take. This is A sphere, this is B sphere, right? So this is somewhat a midpoint here. So in triangle OMA, so I will write this one like this. The triangle is there, right angle triangle. This is O, this is M, this is A. This distance is x by 2, this distance is L. So obviously this is L square minus x square by 4. These are the values. This is the angle theta. Right. By using the triangle law of vectors, by triangle law. So by triangle law of vectors, what we can write? This is F, this is by mg is equal to, see this is F, so opposite side, this is mg, so adjacent side, that is equal to tan theta. So F is equal to by mg, that is equal to tan theta opposite side by adjacent side. So x by 2 by root of L square minus x square by 4. So like that it comes. So f is equal to, we'll write here, f is both are same, so f value I am writing like this from here. F is formula k, both are equal, q square by distance x square is equal to x by 2 root L square minus x square by 4. So this is the equation we got. The values we have substituted here. Mg also be there, sorry, this mg also be there. Given that x is very much less than L, so we can neglect this term. We can neglect this term. Why? Because it is very, very small. Then what we get here, k q square by x square mg is equal to x by 2 root L square is equal to L. So I will get k q square by mg is equal to x cube by 2L. Now what are the constants here? K is a constant, weight is also a constant, 2L, because length of the string never changes, it is not elongated. So I have removed all the constants. So what I got here, q square proportional to x cube. Now q proportional to x power 3 by 2. Right? Let us revisit the problem here so that you can easily understand. See what they are telling. The charges begin to leak from both the spheres at constant rate. So dq by dt is a constant. That's what they have shown, the rate of leakage of spheres. So let us come here. So rate of charge leakage, let us calculate. dq by dt proportional to, I will write this like this, d by dx of x power 3 by 2, but dx is not there. So I will, this is dividing, I will multiply by dx by dt. So dx will cancel, we will get a d by dt only. So like that I have written. So dq by dt proportional to this differentiation, let us do 3 by 2 x power 3 by 2 minus 1 into dx by dt. This dx by dt I just continued. This one only I differentiated. So what I get here, so I have differentiated on both sides. This one q proportional to x power 3 by 2 I have differentiated. Then what happens? Let us see. dq by dt is equal to proportional to, so here 3 by 2 x power 3 by 2 minus 1 is 1 by 2 into dx by dt, displacement by time is equal to velocity. Once again eliminate all the constants. What are the constants? Rate of charge leakage is a constant. 3 by 2 is also a constant. So finally what I got? Finally dq by dt is a constant. So x power 1 by 2 is root x into v is equal to constant. What relation we have to establish? Let us see here. Once again revisit the problem. Yes, this is the problem. Constant rate, that's why dq by dt constant I have taken. As a result, the spheres approach each other with velocity, right? The v varies as a function of distance x. The relation between v and x we have to establish. So here let us establish. Here already came root x into v is equal to constant. So v is proportional to, here proportional to I will write. Why? Because I have taken out all the constants. So if I neglect all the constants, proportionality limit will come. So this will come here. So 1 by root x. That implies v proportional to x power minus half. Like that I can write this root x. So the correct option, let us see. This problem was given in 2016. V proportional to x, v proportional to x power minus half. So third option is the correct option. In this problem, suppose the charge of a proton and an electron differ slightly. One of them is minus E, the other is E plus delta E. If the net of electrostatic force and gravitational force between two hydrogen atoms placed at distance d much greater than the atomic size apart is 0, then delta E is in the order of, given mass of hydrogen is 1.67 into 10 to the power of minus 27 kg. So here two hydrogen atom are there, one hydrogen atom and another hydrogen atom. Two hydrogen atoms are there. They are separated by the distance r. So that is the distance between hydrogen atoms. So in hydrogen atom, we are having one electron and one proton. Electron charge q1 is equal to E minus E given. Proton charge q2 is equal to E plus delta E. So we need the charge of hydrogen. Therefore, charge on hydrogen is equal to q1 plus q2. How much q1? Minus E plus delta E. So minus E and plus E we cancel. So hydrogen atom charge is q. Hydrogen atom charge q is equal to delta E. So this is the charge on hydrogen atom. Now, so we'll write here charge on hydrogen atom q is equal to delta E. Here also q is equal to delta E, right? So this is the charge on this one, and mass of the hydrogen atom also given. So mass of the hydrogen atom, this is mass is m, this hydrogen atom mass is also m, so distance is r. So finally what they are saying from the problem, so what they are saying, electrostatic force is equal to gravitational force between the two hydrogen atoms. So electrostatic force is equal to gravitational force. How can we say the net force is equal to 0? So whenever the net force because of electrostatic and gravitational forces is 0, that means both forces are equal. So let us write the formula here. Right, Fe formula K, both are hydrogen atom only, so both charges are equal, so q square by distance r square is equal to capital G gravitational force formula m1 m2, both mass are same, both are hydrogen atom only, so m square by r square, so r square cancels. So let us write the values. What are the values? We know k value is equal to 9 into 10 to the power of 9 Newton meter square per coulomb square. And what is the capital G value? 6.67 into 10 to the power of minus 11 Newton meter square per kg square. What is the mass of hydrogen atom? 1.67 into 10 to the power of minus 27 kg. What is the charge? Is equal to delta E. That delta E value we have to calculate. Let us substitute the values now. So that implies k 9 into 10 to the power of 9 into q square delta E square is equal to G value 6.67 into 10 to the power of minus 11 into 1.67 into 10 to the power of minus 27. Oh, sorry. I will write separately. Right. So this value, k value, that implies k value 9 into 10 to the power of 9 into delta E square is equal to G value 6.67 into 10 to the power of minus 11. One m value 1.67 into 10 to the power of minus 27 into 1.6 into 67 into 10 to the power of minus 27. So all the values we have substituted. This delta E square value we need. Delta E square is equal to, all numbers I will write one side, that 10 powers I will write separately. So 6.67 into 1.67 into 1.67 by this 9 comes here into 10 power. If bases are equal, we have to add up the powers. So 10 power minus 11, 10 power 27, minus 27, 10 power minus 12. See, all are 10 powers. So bases are equal. Here 10 power 9, bases are equal. So powers we will add up. Minus 11, minus 27, minus 27. This 10 power 9 goes to other side of is equal to, that also becomes minus 9. The delta E is in the order of. Order of means the number is small. So 10 powers are big. So 10 power only, order of means 10 powers. In 10 powers we have to express. So let us do it first. Delta E square is equal to, this is all, if you calculate, comes somewhat at 2.1 into 10 to the power of minus 27 plus 27 54 plus 11 65 plus 9 74. So delta E is order of, I will write like this, order of, see, only 10 powers I will consider, because the root 2 is around 1.14, like that it comes. So only 10 powers we need. So root of 10 power minus 27 is 10 power minus 2 3s are 6, 2 7, so 37, right, coulomb, because this is a charge. So that is the answer. So let us see which option is correct. So in the given problem, third option is the correct option. In this problem, a charge Q is placed at the center of the line joining two equal charges plus capital Q. The system of three charges will be in equilibrium if Q is equal to. So we are having one charge at A, that magnitude is plus Q, and that charge is at B, that is plus Q, So the distance between them, let us take this distance between them is r. Now at midpoint at C, so the distance is r by 2. That a q is there. So if three charges are in equilibrium, let us take this q. Here one force is acting on q. That force is because of capital Q. So if these all three charges must be in equilibrium, this charge, all three charges should be in rest. So some force must be acting in opposite direction so that this q won't move. If this q is not moving, this q also not moves, this q also not moves. So this is a force due to q and q. Force between q and q must equal to force between small q and capital Q. This q charge is in a positive direction. Force between q and q is in opposite direction. So I may say I will put some minus here. So let us write the formula for this one. K q into q square by distance between this q and this q is r. R square is equal to, now force between small q and capital Q. K small q capital Q by distance is r by 2 whole square. Just we have substituted the values. Then what happens? K q square by r square is equal to k small q capital Q by this r by 2 whole square, r square by 4. Now let us cancel away the equal terms. K cancels. 1q and this capital Q also changes. Here minus is there. This minus is there. So what is there here? Minus q is equal to 4q. So q value we have to calculate minus q by 4. So our answer is minus q by 4. So if the charge q value is minus q by 4, all the three charges will be at equilibrium. So the correct option is, in this problem, two small conducting spheres each of mass 9 into 10 to the power of minus 4 kg are suspended from the small point by non-conducting strings of length 100 centimeter each. They are given equal and similar charges until the strings are equally inclined at 45 degrees each to the vertical. The charge on each sphere is. So what they are saying, this is one rigid support. Both are suspended from same support, but the angle between them is 90 degrees. This is the 90 degrees here. So let the distance between them is r. Both are having same charges. We can draw a normal which bisects these two. Each non-conducting string 100, so length is equal to 100 centimeter, that is equal to 1 meter. So this is 1 meter, this is 1 meter, then this r is equal to root 2 meter. Because it is a right angle triangle, it is a hypotenuse. So hypotenuse value is root of 1 square plus 1 square. This is root 2 meter. This is q and this is q. Now when I draw a perpendicular here, this bisects this one. This is 45 degrees. Okay. Now what are the forces acting here? One force is acting here, that is the repulsive force F, and here the mg weight of the sphere is also acting. So here by triangle law, so for triangle law of vectors, what we can say, this f by mg is equal to, see this side, see f can be represented by this side of a triangle and mg can be represented by this side of a triangle. So f by mg is equal to opposite side by adjacent side to angle 45 degrees. So opposite to adjacent ratio is called tan ratio, tan 45 degrees. So f by mg is equal to tan 45 is 1. So we can write here, therefore f is equal to mg. So let us now write the values. K, q1, q2 both are equal, so k q square by the distance r square is equal to m into g. So let us substitute the values here. Now k value 9 into 10 to the power of 9 and q value we don't know, q square, and by r value is root 2 whole square. M value given 9 into 10 to the power of minus 4. G value is 10. So all the values we have substituted. So now q square value we have to calculate. Here this side 9 is there, this side is 9 is there. So they will cancel each other. This 10 and this 4, 1 goes 10. So 10 to the power of minus 3 will be there. So here how much is there? Q square into 10 power 9 root 2 square is 2 is equal to 10 power minus 3. So now we need a q square value. So that implies q square is equal to 2 into 10 to the power of minus 3 into 10 to the power of plus 9 goes that side, minus 9. So q square is equal to 2 into 10 to the power of minus 9 plus 3, 12. This is q square value. So q value is equal to root 2 into 10 power minus 12. So q is equal to root 2 is 1.414 into root 10 to the power of minus 12 is 10 to the power of minus 6 coulomb. So this is our answer. Let us check which option is having the correct answer. So here first option is the correct option. In this problem, two pith balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is r. Now the strings are rigidly clamped at half the length. The equilibrium separation between the balls now becomes. So let us solve this problem. In the first case, two balls are at r distance. In second case, it is clamped at y by 2 distance. So we have to establish the relation between r and y. Let us do so. See, this charge is plus q. Here also charge is plus q. So distance is r. In this direction, force, Coulombian force, repulsive force is acting on this one, and vertically downwards its weight is acting. So if we draw a line here, this is a normal. So this is a theta. So by using triangle law, by triangle law of vectors, law f by mg is equal to tan theta. Tan theta f by mg is equal to, see, this side of the triangle, right angular triangle, represents this force. This straight side of this triangle represents mg. So that is the right angle triangle law. If two forces are represented both in magnitude and direction by the two sides of a triangle taken in order, then the closing side, the third side, in reverse order will give its resultant. That is the definition. So f by mg is equal to, this is representing, this is a perpendicular bisector. So this length is r by 2. So this is r by 2 by this one. This side is y. That's all. So now let us write the expression for the force. K, both charges are equal, kq square by distance is r square, is equal to r by 2 by y. Let us simplify further. So that implies, see here, kq square, I will further write in a r by 2y, like that. So what happens here, whatever the constants are there, let us eliminate them. So k, q, these are all constants, and r square is not a constant. So here this 2 is also a constant. Then what we got, this r square goes to here. So r cube proportional to y. That implies r proportional to y power 1 by 3. This is the relation we got. Right. Now let us come to this one. This diagram. In this diagram, see, in this diagram, this is the force, this is the weight, and this is let us take this is our r dash. So this side is r dash by 2, this is y by 2, this is angle theta. So here, without writing all these things, see here r proportional to, see, since r proportional to y power 1 by 3, this is the relation between r and y. Here r dash and y relation is, that implies r dash proportional to, here in the place of y comes y by 2 whole power 1 by 3. So that implies r dash proportional to, see this y power 1 by 3 by 2 power 1 by 3. So that is equal to r dash proportional to y power 1 by 3 by, see, this is cube root of 2. So this is the relation, separation between the two pith balls when the string is clamped at the middle of its length. So let us see which option is correct for us for this problem. See r by, see here one more step I forgot to write, so let us write that one also. See, from this r dash proportional to y power 1 by 3 is, see, y by power 1 by 3 is r, small r. So small r by cube root of 2. So this option they have given. So the correct answer for this question is 2. That is the correct answer. In this problem, in the basic CsCl crystal structure, Cs plus and Cl minus ions are arranged in a BCC configuration, body central cubic configuration, as shown in the figure. The net electrostatic force exerted by the 8 Cs plus ions on Cl minus ion. See, this is a BCC structure. So at the center, chlorine will be there. At the center, chlorine will be there. So here you see, this is a cesium ion. Diagonally, this is cesium ion. So this is also plus, this is also plus. So the middle, in the middle of the center of the crystal, Cl is there, chlorine is negative. So this cesium will attract this towards it, and other cesium ion along the diagonal, it attracts in its direction. This cesium, diagonally this ion, both will attract the central chlorine negative ion into towards itself, like that. So here also this cesium and diagonally this one, and this cesium diagonally this one. So all the Cs plus ions will attract Cl minus ion at the center equally in all directions. Because of this, the net force on chlorine is equal to 0. So electrostatic force exerted by the 8 Cs ions on Cl minus ion in BCC configuration is 0. So let us write this one as all the Cs plus ions on the diagonal of BCC crystal equally attract the Cl minus ion at the center. So due to symmetry, the net force is 0 on Cl minus. So the net electrostatic force is 0 on chlorine. So answer is fourth option is the correct option. In this problem, a particle A having charge 9 into 10 to the power of minus 6 coulomb and a mass of 2 kg is placed at the bottom of a smooth inclined plane of an inclination 30 degrees. The distance of another particle B of same mass and a charge should be placed on the inclined plane so that it may remain in equilibrium is. So here let us consider an inclined surface. This is the inclined surface. Angle of inclination theta is equal to 30 degrees. Here particle is there, a small particle. This mass is 2 kg and charge is q. And we placed another particle here. This is particle A, this is particle B. It is also having same mass and same charge. Mass is equal to 2 kg and charge is q. The distance between them is r. This distance we have to calculate when these two particles are in a equilibrium. Actually, when we place a particle or sphere, any object on inclined surface, this inclined surface is smooth inclined surface. So it will slide down, but it is not sliding down means, see, this is positive, this is positive. In this direction, the repulsive electrostatic force is acting. Here, whenever on whatever the surface it is lying, to this surface I draw a normal. This is vertically downwards, the weight of a particle acts. So this is this is also theta. This is a component of weight mg cos theta. So downwards the component is mg sin theta. See here, when the force diagram we have drawn, it is very clear. If body is sliding down on a smooth surface because of the force mg sin theta, but the B particle is not sliding means the repulsive force of electrostatic repulsive force, the Coulombian force, is acting in opposite direction. If these two forces are equal and opposite, then the body will be in equilibrium. It cannot slide down, right? And it also not able to go up because of this repulsive force, because these two forces are putting this body in equilibrium. So here the condition for equilibrium, therefore the condition for equilibrium, what is the condition for equilibrium here? This electrostatic force is equal to mg sin theta. Mg sin theta is the component of horizontal component, the component parallel to the inclined surface, weight component of a particle. Fe is the electrostatic repulsive force between two particles having same charge q. So let us write the formulae, respective formulae. What it is? K, both charges are equal, so q square, distance is r square, that is equal to mg. Mass of the body, see, let us list out whatever the data they have given in the problem. So what the data they have given in the problem, mass of a particle is given as 2 kg. Charge on the particle is given as 9 into 10 to the power of minus 6 coulomb. The constant k, 1 by 4 pi epsilon naught value, 9 into 10 to the power of 9 Newton meter square per coulomb square. So these things we know. So these values we substitute, and also we know g is equal to 10 meter per second square, acceleration due to gravity. Let us substitute all the values here. And theta also, this theta is also 30 degrees given. So mg sin 30 degrees. So now what is k value? 9 into 10 to the power of 9. Q square, q is 9 into 10 to the power of minus 6 into 9 into 10 to the power of minus 6 q square by r square. This r value we have to calculate, is equal to mass of a body 2 kg, acceleration due to gravity 10, sin 30 degrees is equal to 1 by 2. So these two will cancel each other. Now I will place this r this side. I will write here like this, and this 10 means 10 power 1. When it comes to this side of is equal to, it becomes 10 power minus. So all numbers I write first, 9 into 9 into 9, and When bases are equal, we have to add the powers. So 10 power 9 minus 6 minus 6. This 10 power minus 1 also comes this side. Na? So this is minus 1. So now r square is equal to 9 into 9 into 9 into 10 to the power of this is 6 6 12 13. 13 minus 9 4 minus 4. Now I will calculate the r value. We have to calculate the r value. R is equal to root 9 is equal to 3. Root 9 is equal to 3. Root 9 is equal to 3. Root 10 power minus 4 is 10 power minus 2 meter. Right? This is the answer. Let us simplify this answer. That is equal to 3 3s are 9, 9 3s are 27 into 10 power minus 2 meter. That is equal to 27 centimeter. This is our answer. So let us check which option is correct. So in this problem, first option is the correct option.